In the annals of human history, the drive to create weapons of immense power has left an indelible mark, shaping the course of nations and the fate of millions. Among these, the Tsar Bomba stands as a stark reminder of our capacity for destruction, a symbol of the extreme lengths humanity can go to assert dominance. This Soviet-era thermonuclear bomb, detonated in 1961, remains the most powerful explosive device ever created by humankind, a testament to the era's technological advancements and geopolitical tensions. Its test blast yielded an unimaginable 50 megatons of TNT equivalent, a force that dwarfed even the devastating power of the atomic bombs dropped on Hiroshima and Nagasaki, showcasing a new level of destructive capability. The Tsar Bomba's mushroom cloud soared to a staggering height of 64 kilometers, visible for hundreds of miles, a sight that left an indelible impression on all who witnessed it. Its shockwaves circled the globe multiple times, a testament to its raw energy and the far-reaching impact of its detonation. The bomb's development marked a turning point in the Cold War, a chilling demonstration of the destructive potential that humanity possessed, and a stark reminder of the fragile nature of global peace. It served as a stark warning, a reminder of the precarious balance upon which global peace rested, and the dire consequences of tipping that balance. While the Tsar Bomba's test occurred over the remote Novaya Zemlya archipelago in the Arctic Ocean, its legacy continues to resonate, echoing through the corridors of history. The sheer scale of its power inspires awe and fear, prompting us to ponder the hypothetical consequences of its detonation in different environments, and the potential for even greater destruction. One such thought experiment involves the deepest point on Earth, the Mariana Trench, a place of immense natural pressure and mystery. What if this weapon of unparalleled destructive force were unleashed at the bottom of the Pacific Ocean, in the abyssal depths of the Mariana Trench? The implications are both fascinating and terrifying. The scenario, while purely hypothetical, allows us to explore the interplay between human-made power and the awe-inspiring forces of nature, and to reflect on the responsibilities that come with such power. The Mariana Trench, a crescent-shaped scar on the Pacific Ocean floor, plunges to a depth of almost 11 kilometers, making it the deepest part of the world's oceans. This region of perpetual darkness and crushing pressure represents one of the most extreme environments on our planet, where life has adapted to survive against all odds. It's here, in this alien realm, that we imagine the detonation of the Tsar Bomba, a scenario both terrifying and captivating, pushing the boundaries of our understanding. At the moment of detonation, the bomb's nuclear core would reach temperatures exceeding 100 million degrees Celsius, hotter than the core of the sun, unleashing a fury of energy. This unimaginable heat would instantly vaporize the surrounding seawater, creating a rapidly expanding bubble of superheated steam and radioactive plasma, a phenomenon of immense power. This bubble, driven by immense pressure, would surge outward, compressing and heating the water in its wake, creating a dynamic and violent reaction. As the bubble expands, it would create a cavity of water vapor and radioactive nuclei, a void in the immense pressure of the deep ocean, a temporary space of chaos. This cavity, however, would be short-lived, collapsing almost as quickly as it formed. The immense weight of the surrounding water, millions of tons pressing inward, would cause the bubble to collapse in on itself with unimaginable force, a cataclysmic implosion. This cycle of expansion and collapse would repeat itself in rapid succession, generating a series of powerful shockwaves that would radiate outwards through the ocean depths, a relentless pulse of energy. These shockwaves would carry the devastating energy of the Tsar Bomba, but their impact on the surface world would be far less catastrophic than one might imagine, a hidden terror beneath the waves. The popular imagination often conjures images of towering tsunamis, triggered by underwater earthquakes or volcanic eruptions, wreaking havoc on coastal cities, leaving behind a trail of destruction and chaos. Given the Tsar Bomba's immense power, it's natural to assume that its detonation in the Mariana Trench would unleash a similar cataclysm upon the world. However, the reality is far more nuanced and complex. The immense pressure at the depths of the Mariana Trench acts as a powerful containment force unlike anything on the surface. The weight of the water column above the detonation point would suppress the outward expansion of the initial blast, containing its energy. While shockwaves would radiate outwards, their energy would be significantly dissipated by the time they reached the surface, losing much of their destructive potential. Instead of a towering tsunami, the surface manifestation of the detonation would be surprisingly muted and less dramatic. Observers might witness a large area of bubbling, churning water, perhaps a dome-shaped plume rising a few hundred meters into the air, a sight both eerie and fascinating. This plume would be composed primarily of superheated steam and gases, carrying with it radioactive fallout from the explosion, posing a different kind of threat. The absence of a devastating tsunami, while counterintuitive, highlights the importance of pressure in this scenario, a crucial factor often overlooked. The ocean's depths, far from amplifying the bomb's destructive power, would actually serve to contain it, preventing a global catastrophe and showcasing the ocean's natural protective mechanisms. Section 4. Echoes in the deep environmental impacts on marine life. In this section, we will delve into the geological stability in the face of nuclear power. How do we ensure that our advancements do not disrupt the very ground we stand on? Finally, let's take a step back and gain some perspective on Earth's grand scale. From the tiniest microorganisms to the vast landscapes, each element plays a crucial role in our planet's intricate balance. If you like this content, then don't forget to like and subscribe and hit that bell icon for notifications on future videos.